Okay, I wanted to make a little video of all of the Chapter 6 review problem solutions, so you guys would have the weekend to study all the correct answers and then do really well on Monday. Okay? So this first one, you just want to make sure that you add 10 to both sides, and when you do that, of course, it's going to be a is less than 8. And then a lot of these we did work out in class, the first several. And then number 2, the two negatives right here, that becomes a positive. So then you want to subtract 2 from each side, and that's why you have negative 20 right here. So s is greater than or equal to negative 20. If you want, you can also write, and it's a little bit tough to see, but you see, okay. So then you can write s is greater than or equal to negative 20 as well. Wow, this part's a little bit harder with this. Okay. And then number 3, what you want to do is subtract 3x from each side. And so if you do that, that'll be 9x right here, and then these cancel out. So that's negative 4, and then you divide by 9. So that's negative 4/9 is greater than x. Or you could have, not that. Or you can say that x is, x is less than negative 4/9 as well. Okay. So it's a little tougher to do with this thing and trying it. Okay. Okay. So then number 4, we did that one as well, multiplied by the reciprocal, and we get negative 20 over 14, and then we reduce it, and we get negative 10/7. Number 5, you want to get your x's together, so you add 2x to each side, so that's 5x, and then I added 2 to each side, so that made it 10 on this side. Then I divided by 5, and so that's where I get my x is greater than 2. Okay. On number 6, you've got to get the m by itself, so you got to get rid of that positive 10, so you got to subtract it. So I subtracted both sides, subtracted 10 on both sides, so negative 3m is less than negative 30, and then we need to divide by negative 3. So I divide negative 3 on this side, negative 3 on this side, and then it's m, and because I divided by negative 3, then it's m is greater than, I got to switch it, and then this becomes a positive 10. Okay. On number 7 there, distribute the 3, so 6y minus 24. This side's fine, and then we want to get the y's together, so I subtracted 3y from each side. That's where I got the 3y here, 6 minus 3. And then added the 24 over to that side. Negative 20 plus 24 is positive 4. And then I divided by 3 on both sides, so y is greater than 4/3. Number 8, you want to use the distributive property again, so 15x minus 10. And then this side is 3x minus 90. And I subtracted 3x from each side, so that became 12x. And then I added 10 to each side, and that became negative 80, negative 90 plus 10. Then I divided by 12, and so I got negative 80 divided by 12, and then I took out a bunch of 4s, so I divided top and bottom by 4. X is greater than or equal to negative 20 over 3. On number 9, the problem, if you want to write it as an inequality, is negative 3/8 x is greater than or equal to 98, and then you multiply by the reciprocal, so negative 8/3, negative 8/3. These cancel out really well, so the 8's cancel out and the 3's cancel out, and then on the right side, wow, this is really tough to do with this document. On the right side, the 98 times 8, you just multiply them together. So 784, it's a negative, and then divide by 3. So that would be okay. This was before we were able to use calculators really, so now we actually could get a better answer with the calculator. Okay, the graphing, the y-intercept here is -2, so put a dot at -2, and then the slope is 2/3, so we just go up 2 over 3, put another dot there, and then that's a dotted boundary right there. So then we need to determine the shading. So then we do a test point, and I did a test point as 0, 0, and I plugged that into the original, and I got 0 is less than 2/3 times 0, and then minus the 2. So 0 is less than 2, less than -2, and that is actually false. So that means 0, 0 is not the shaded region, so we shade this side. Number 11, I had to get it in slope-intercept form first, so I subtracted 3x, and that became -2y is less than or equal to -3x plus 12. And then I divided by -2, and that got the y by itself. But I also reversed the inequality because I divided by negative. That's positive 3/2 x, and then minus 6 when you divide that by -2. Number 12, I had to solve this one just by dividing by 3, and so that became x is less than or equal to 2. And then this one says that x is greater than -5. So, and this is an and problem, so I'm looking for where they overlap. So x is less than or equal to 2, goes that way. X is greater than -5, it's open circle, goes that way, and they would start overlapping right in the middle there. Number 13, I subtracted 6, so that became a 2. And then I divided by -2 on both sides, and I had to reverse the inequality, and that became -1. And then this one was already ready to go. It's an and in the middle. X is less than 3, open circle, going to the left. X is greater than -1, going to the right. They're overlapping in the middle. Number 14, got to solve this one on the right. So you subtract 1, so that's -3. And then you got to divide by 3. So that's x is less than -1. And this one's already ready to go. So x is greater than or equal to -4. It goes to the right. This is less than -1. It's open circle, goes to the left. This is an OR problem. And so when you put those two graphs together, like everything's covered on the number line. So this is actually all reals. To say it correctly, it's actually every number on the number line is covered by either this one or this one, so we say all reals. If this was an and problem, then we'd only have the middle part that we would say is the solution. Number 15, you want to subtract 2 from each side, or all three parts really. So -4 minus 2 is -6, 10 minus 2 is 8, and so all the numbers in between -6 and 8 are the answer. X is greater than or equal to -6, close dot. Less than 8, open dot. Okay. Number 16, we have two cases. First case, you don't do anything. You take away the bars. Second case, you make the 17 a -17. And then you start solving. So on this one, you got to get rid of the 3. So you subtract it. That becomes 14. And then you divide by -5. So that's -14 over 5. Over on the right hand side, you subtract 3 from each side. That's -20. Divide by -5. That's x is 4. So the answer, if you graph it, it's just two dots. One at 4, one at -14/5, which is a little bit less than, well, a little to the right of -3, really. Okay, on 17, you have your two cases. So the first case, you rewrite it without making any changes. Take away the bars. The second case, you rewrite it. You take away the bars. You reverse the inequality, and you change the sign. And then you solve it. So we subtract 2 from each side. So 1 minus 2 is -1. And then we divide by -1. So x is less than. We got to reverse the inequality because we got to divide by a -1. Or multiply by -1. It's the same thing. Either way, you got to reverse the inequality. Over here, same thing, you subtract 2, so that makes it negative 3 on the right-hand side. Then divide by a negative 1, so that means you got to reverse the inequality. So x is greater than 3 now. So if I graph it, it's an OR problem, so I do open circle at 3, goes to the right because it's greater than. X is less than 1, open circle, goes to the left, and that's okay. It's an OR problem. They can go out like that. Number 18, you want to do your two cases. So first case, just rewrite it as it is. Second case, rewrite it, take away the bars, but reverse the inequality and change the sign on the right-hand side. And then you solve. So you subtract 8, and then divide by 4, so x is greater than or equal to 2. Then over on the right, you subtract 8, so that's negative 24. Then divide by 4, and that's negative 6. So this means that x is less than or equal to negative 6, so close dot, goes to the left. This one is x is greater than or equal to 2, so close dot, goes to the right. That's an OR problem, so it's totally fine that they go left and right. And this is a great TOR, so great TOR, greater than or equal to, so we know it's an OR. This is the shortcut. This absolute value of 2x minus 1 is greater than a negative 7. That's always going to be true because the left side's positive. A positive number is always bigger than a negative number. So all real numbers. So actually, if we were doing a nice job on this, the graph on this is the whole number line like this. You show it like all reals and you shade them all in. Okay. Alright, this is tough. Let me get over here. Okay. So then the last problem is application. You have all these scores, and these are your first 4 scores, and then you got a 5th score you don't know, so you add your x, you divide by 5 because there are 5 scores. You're trying to figure out an average of at least 70, so that's greater than or equal to, and you add those up. That's 256 plus x. And if you want to solve for x, you got to multiply by 5. So that's 256 plus x, and that'll be 350 on the right-hand side. And then subtract 256 from each side. X has to be greater than or equal to 94. So this person needs a seriously good 5th test score to get a 70 average. And that's because of this horrible 55 and 62. That hurt him. So if he wants to have a C average, he really needs to make up for it with a really great score. Okay? 13 minutes. That's all I need to know for the test or celebration on Monday. Okay.